Hello everyone, welcome. We are solving a Leetcode problem, Leetcode 322, coin changer. So this is a dynamic programming problem. You are given an integer array coins represented coins of different dimensions, and an integer amount represented a total amount of money. Return the fewest number of coins that you need to make up that amount. If that amount of money cannot be made up by any combination of coins, return -1. You may assume that you have an infinite number of each kind of coin. We're gonna be talking about this later, the infinite number. Example 1. The input is coins 1, 2, 5. So this is a coin of value 5, this is a coin of value 2, this is a coin of value 1. The total amount is 11. The output may be 3. So the explanation is 5, which is the biggest coin, plus 5 equals 10. We cannot be adding more 5 or a 2, so we'll be adding a 1. So we have the second example, input of coins, we have one single coin. It cannot make 3. It will be 4. 2 plus 2 is 4. That's why the output is -1. There is no combination. You have another thing, coins, 1, amount, the amount is less than the coin. So we return 0. Okay, first of all, we're gonna be initializing the dynamic programming array. So one second. Here we do amount plus 1, amount plus 1. So let's explain this. The purpose of this is initialize a dynamic programming array to keep track of the minimum number of coins needed to make up every amount from 0 to the given amount. So the explanation is the dynamic programming array is initialized with a size of amount plus 1 because we want to cover all amount from 0 through amount. Each element is initially set to amount plus 1, which represents infinity in this context. Since it's more than 1, it's more than the maximum possible amount. This initialization ensures that any actual number of coins needed will be less than these initial values. So that was why he said this. You can assume you have an infinite number of each kind of coins, allowing us to correctly identify and update the minimum number of coins required for each subproblem. So we're gonna be talking about the subcase. DP, which is the dynamic programming array of 0, will be 0. So the purpose of this will be to set the base case for the dynamic programming array. The base case states that no coins are needed to make up an amount of 0. This is a logical starting point since we have no amount means we don't need any coins. Anyways, we need now to fill the array for e in range 1 because we skipped the 0. We skipped it, amount plus 1. Okay, for coin in coins, so for coin in coins, which is the other array, if I bigger than coin, then dve my minimum of dbi I minus coin plus 1. Let me explain the purpose of this. To fill the dynamic programming array by iterating through every possible amount from 1 to the target amount, and updating the minimum number of coins required for each amount. The explanation: the outer loop, this loop, for E in range 1 amount plus 1, iterates through every amount from 1 to amount. The inner loop, this, for coin in coins, iterates through each coin denomination. So, for example, 1, 2, and 5. Okay, the condition if I bigger or equals coin checks if the current coin can be used to make up the current amount I. If so, we update dpi with the minimum between the current value and dpi minus coin plus 1. Here, dpi minus coin plus 1 represents this scenario. We represent this scenario where we used one coin of the dimension coin to set up part of the amount, and the rest, I minus coin, is made up by the minimum number of coins found for the smaller subproblem. This iterative process builds up solutions for larger amount based on solutions for smaller amount, leveraging the principle of dynamic programming. You really need to understand this principle because it has many other problems. Anyways, now guess what we will do? Of course, we will return the result. Return minus 1 if db amount equals amount plus 1, else return amount, db amount. So this is it. That was the problem. It was as you see at it gets. So this is a medium problem, but it's quite easy if you understand dynamic programming. The purpose of the return is to return the final result. If dp amount still equals amount plus 1 after filling the dp array, it means we couldn't find a combination of coins that sum up to the given amount. So we return minus 1 to indicate the impossibility, like the example 2, for example. It's impossible to do it. Otherwise, dp amount contains the minimum number of coins required to make up the given amount, so we return this value. In summary, this dynamic programming approach solves the coin change problem by systematically building up solutions for all amounts from 0 to the target amount, leveraging the principle of optimality. The optimal solution to a problem can be constructed from optimal solutions of its subproblems. By filling the dynamic programming array in a bottom-up manner, we ensure that when we calculate the minimum number of coins for a larger amount, we have already solved the problem for all smaller amounts, allowing us to construct the optimal solution efficiently. So that was it. Let's submit it. Oh la la. So we have in line 9. I'm quite sorry. Let me see what's wrong. Yeah. I just forgot that. I'm so sorry. So it's quite a good approach, really. It beats 180, 81% of people. Anyways, that was it. Goodbye.